Hi, and welcome to this session about using Office Graph APIs of the Office 365. My name is Vincent Barrett. I'm a SharePoint MVP for 2 years now. I'm living in Montreal, Quebec, Canada, and I'm working as a products team tech lead at Negotium Technologies, which is a Canadian company. If you want to contact me, you will find my Twitter, my email, my blog address, and so on. So feel free to reach me out during or after the session if you have any question. Before we begin, just know that this session is pre-recorded, so if you have any question, feel free to ask them the question on the chat. I will be on the chat answering your questions and trying to answer as many questions as possible. So, who's that session for? This session is mostly targeted towards end users who want to understand the value of the new Microsoft Office graph, and also it's targeted towards developers who want to understand the concepts and how they can integrate the Office graph into their applications. Before we begin, if you want to dive deeper in the concepts and the technical skills we are trying to develop here, you can check out the Ignite sessions and also one session about graph databases for SQL professionals, which are available online and you will find easily online. So check those sessions out. It's very interesting and you will learn plenty of stuff in completion. So today's agenda, we will first begin by introducing the graph theory and how it works, what it is, and what are the new paradigms and what we can do with that. And then we will have some little demonstrations with very graph-oriented, dedicated technologies and see how we can play with that and get familiar with this new concept. Once we've done that, we will talk about the Microsoft graph, explain why Microsoft is building a graph and what you can expect out of it and what value it's going to bring. And then we'll see some demonstration during the whole session. So today I won't be showing Office Delve. Delve is only a client of the Microsoft Office graph. It's a web-based client. I think you've already all seen it, and I won't be showing that. Also, I won't be showing Power BI. With Power BI, you can do some reports and some charts and so on, and you can use that to do some reports based on graph data. I won't be showing that, but please keep in mind that's also a possibility. And we won't see too much code, just a bit of code. So stay tuned. If you're not a developer, you will be able to understand what I'm saying. So the first part, what is the graph and how it works and what are the concepts included. But just some quick examples and quick questions to make sure we all talk about the same thing. Is this a graph? No, that's not a graph. That's a bar chart and that's only a way to visualize data, but that's not the graph we're going to talk about. Same thing about this one. This is a pie chart, but this is not a graph, and just that you know of, and we talk about the same thing. So what's a graph, you are going to ask me? That is a graph actually. That's a graph. We'll explain it more in details later during this session. A graph is only a set of connected objects together with sometimes some properties, but it's more data structure in a mathematical theory than something visual. That's only a way to represent a graph, but a graph is just a theory of storing data. And why is everybody currently investing on graph databases, graph APIs, and graph theory, and so on? Well, everybody came to a realization lately that RDBMSs, so the relational database management systems, are not very good at doing things that they are not meant to do. Basically, at the beginning, RDBMSs were meant to store forms data, so very structured data, very the input and so on, but they are not meant to store connected data or related data. Sure, you have a relational database management system that came later with the foreign keys and so on, and the joins and stuff like that. But at the beginning, our DBMSs were not meant to store highly connected data and things like that. So that's why everybody right now is investing on new graph database management systems, new graph APIs, and so on. So that's one of the reasons. When you think about database, most developers only think about RDBMSs and this paradigm, and they only know that, and they always want to store their data into that kind of database management system. But please keep in mind that you have plenty of different database management systems. For example, from the old mainframes, we have what we call the navigation database management systems, which later on evolved in the hierarchical, I'm sorry about my accent, database management system, where you store data in a form of a tree where nodes are related to their parents and so on. So that was one way of storing the data. Obviously, it was not very practical, so it quickly evolved in our DBMSs and stuff like that we use mostly nowadays. But again, even nowadays, we still don't have only this kind of database management system. We also have NoSQL database management system, which allow us to store unstructured data, non-related data, and so on. We also have things like search indexes. So it's not really a database management system, but again, it stores a lot of data. The data is most of the time flat, and that's one way to store data, or huge amounts of data. Also, we have, because our relational database management systems are not very good at navigating between connected objects, when we wanted to extract relationships or insights between the objects we store in those database management system, we've had to find some tricks or some fixes or dirty solutions, I would call, in order to be able to do mass calculation and mass navigation between all the objects we have. So we had to do things like denormalizing our database management schema, like extracting some data cubes and so on, in order to be able to generate some reports. But again, that's not very efficient. That takes a lot of power, that takes a lot of time, and the main reason why we do that is because our DBMSs are not meant to store connected objects, and when you want to do mass calculations based on relationships, they are not very good at it, so it won't work properly. You will have to find solutions. So that's why everybody is investing right now in a graph database management system. So at first, the graph was only a mathematical theory, and it was only a way to conceive objects and to be able to navigate from one object to another one, and we'll see how it works later on. But it was only a theory from mathematics. Then us developers said, oh, this is useful, and maybe we should use that with our computers and so on. So we tried to implement applications of this theory, and one of those is the property graph. So the idea of that is you will have two kinds of objects or entities you will manipulate. The first one being the object itself, or the node, sometimes it's called like that, and the other one is the edge or the signal or the relationship. And on those two objects you will also find some properties. So here is a representation of graph objects in my company. So I, Vincent, am a node of this graph representation. I'm an object of a type person. Even if when I'm talking about types, it's not strongly type. The type can be dynamic, and the properties can change from one object or another. It's just one of the properties of the object. So I, Vincent, have multiple properties. I work at the desk E43. My phone number is this one. My extension is 275, and so on. So each object has properties. And then we have other objects, like the company I work at. which is actually negotiation technologies. We have other properties like street address, the date of creation of a company, and so on. And then we have other kinds of objects, which are the roles in the company. So as Vincent, as a person, I'm also a technical advisor, so I have to technical advise my coworkers. And one of the advantages I get with that is I have a fancy business card and so on. But I'm also a developer, so what I must do is some development, and one of the advantages I get is I have better keyboard and so on. So you get the idea. And connecting these objects, you have a relationship or edges or links and so on. And these connectors can have also can have properties. So I've been working at Negotium since 2012. I've been working at Negotium as a developer since 2012 too. I've been a technical advisor since 2014 and so on. So thinking differently, you're not thinking anymore in matter of tables, in matters of queries and so on, but you focus more on the semantic of your objects, what they really represent and how they are related together, and what properties they have. And you will just put three objects in the graph and not care anymore about how you retrieve them or how you store them, but more about how are they related together and how they work together. And one of the questions you might ask yourself is, we're using more and more graphs in computing, but why are computers so good at working with graphs? Basically, if you study the graph theory, you will find that all the graphs and the relationships and all the paths you can use to move from one node to another one can be represented by matrices. And those are only huge arrays of numbers, and computers are very good at manipulating those because they are very light, and native CPU operations on these matrices are implemented right in the hardware. So this is why they're very, very, very efficient at manipulating those. And it uses low memory and so on. If we try to think about the applications we've been already using every day, one of those is the internet. The internet, the way it works is for your computer to be able to reach another computer across the globe and to find the route between point A and point B. Basically, all the routers between all these points have some what we call routing tables. And how is this represented? It is represented as matrices. And because they have the ability to quickly work with these matrices and to quickly apply some path-finding algorithms, this is the way that the packet from point E goes to point B without getting lost, without any latency, and so on. So one of the most famous applications is the internet. Another application is the GPS. Again, to find your route, the GPS device has some maps, and those maps are basically the path between point A to the path possibilities between point A to point B, and stored as matrices and so on. And again, the GPS device will use some path finding algorithms to be able to go to point A to point B. And if you think about it, if you think about the size of the map and the quantity of data and the amount of data and so on, and the size of a GPS device and his calculation capability, it's very, very efficient, a very efficient way to use a CPU. Another usage of that is the fraud patterns, detection patterns in the banks. So the fact that you're using your credit card for a certain amount at a certain place and you have different habits and so on is one way to detect, based on the graph theory, whether or not you should use this credit card and whether or not they are going to allow the transaction and so on. Another application is IMDb. the famous website imdb.com. It's a website about movies and actors and so on. And the way they store all their data is using a graph database. And you have thousands of real life applications which are on production and work way better because they have chosen an adequate way to store their data. So enough with the theory, let's talk about some applications and demonstrations. So what I'm using here is something called the Neo4j. So basically this is one of the available graph database engines on the market. This one is open source, and you can within Azure use a Neo4j machine. You will just have to click on the template and it will install everything for you, ready to play. You just have then to feed your data, and you will be able to play with that. So this is a really great tool to be able to understand how it works and how you should design your applications, design your entities, and the way you're going to store into the database management system, and to understand how everything works. Plus, they have some really good ebooks to be able to read about the subject and get used to it and so on. So what I've done basically is I have on my personal blog used a crawler which crawled every article on my personal blog and used the semantic API to extract all the entities I'm talking about, all the concepts I'm talking about, and so on, and to be able to have some insights about what is my blog talking about generally. And once you do that, it has extracted all the entities and so on, and all the relationships between the documents, entities, concepts, and so on, and it will push that to the graph database management system. I've actually already done that for you, so we don't have to wait for that. And it will create the whole representation of my blog and all the concept and all the entities within it in the graph database management system. And once we have our data loaded, basically, we're ready to play with that. So the first request I'm going to execute might slow a little bit my browser. That's not because of the graph database engine, that's only because we have a lot of points to represent in the browser, and it starts to freak out. So this request will tell to the, so this request here will tell multiple things to the engine. I want to extract items which are related together. So basically, and you can see that's a visual representation of a request. You don't have to say select, from, join, but and so on and so on. You just draw the relationship you want to express to the database management system. So basically what it's going to do, it's going to extract everything which is related to anything. So this is one of the most basic requests you can use in a graph database management system. If I run that, we can say that we have tons of data, and again this is lagging only because of my browser, but not because of a database management system. It only took a few milliseconds to execute and to retrieve all that data. And if I toggle that to full screen mode, what we can see is here we have a description of each color. The blue points are documents, so basically blog posts for me. The red ones are languages, so is it written in French or in English, because I write on my blog using 2 languages. The purple ones are entities, so entities are things like companies, persons, and so on. Concepts are in cyan. A concept is more an idea or anything like that, and then the pink ones are the keywords I'm using in my articles. So without any intelligence in our request, because this is a graph database management system, we can quickly see the clusters and the fact that some articles are related together and talking about the same concepts, and maybe grouped together and so on. So it gives out of the box without doing anything, but only because we use the proper way to see connected entities, insights about what's going on and what I'm talking about and so on. So once we have that, let's try other requests, which will retrieve more interesting things. This one is going to extract all the documents which who have the language associated with those. So basically, it will only retrieve me documents and languages. As you can see, the API I'm using to extract the language is not that great, so we'll have 2 documents coming out, but we can see that this document is in English, and this one and this other document is in French, probably. Yep. Now let's do something more interesting. Let's use this request. So this one is going to do something a little bit different. We want all the documents talking about, well, all the concepts which appear in a positive way in a document. So this is another interesting thing. So we can see that we quickly and easily can express some conditions and some requirements to the entities and so on, and the objects and the relationships we want to manipulate. Let's run this one. So basically, this document is talking positively about database server, Java, company, well, the cloud, the developer job, and so on, the company Microsoft, and so on. This other, so let me just put that on full screen. Document is talking positively about Thomas and the Himalayas and so on. So again, we can express some more complicated requests very easily. If you think about it again, this will have required multiple tables, some complicated joins to do. It might have taken like a long time to perform and so on. So this is why Graph Database comes very handy and very useful to do these sort of things. But let's try something even more complicated. Let's try to extract all the documents talking about Chicago. So again, same kind of query. We just want to express the constraint that we want anything talking about Chicago, and I hope I still have blog posts in my, we only have one coming out now, but again, you can see that it's very easy to express some constraints. Let's try to extract all the documents now talking about Microsoft. And we have multiple ones talking about Microsoft. Then let's try something even more complicated. Let's try to extract all the documents which talk about Microsoft or Chicago first, and talk about both of these concepts actually. We can see that quickly we have one document which talks about probably the Ignite actually, and is talking about Microsoft and Chicago. And the way we express that again is in a very visual way. As you can see here, the first thing we wanted to have is an entity which appears in a document. And then again, see the direction of the arrow and so on. We wanted another entity which appears in the same document. And then what we expressed was the constraints that first entity has to be Microsoft and the other one has to be Chicago, and we returned everything to be displayed. But again, let's think about that in RDBMS way of storing things. You would probably have to add a document table with an entity table with some relationships and do maybe 2 or maybe 3 joins and some complicated constraints and so on. And here you only have to express visually your request, and it's way more performant. That's what we are going to try. is this one. So this one is a bit different in the way that we want everything between 1 to 5 nodes separating Microsoft and Chicago. So again, first we try to get a first entity and another entity which are constrained to Microsoft and Chicago here, and between those can be either one document connecting both of them, or one document, another concept, and another document, and so on. So we can see that pathfinding and seeing connected objects becomes way easier than it is with an RDBMS and so on. So if we execute this one, take a little bit longer, and you can see the difference here. Because we wanted only at first the entities directly related to a document together, we only had 3 items coming out, right? But here, because we allow a way to have items connected, but by multiple nodes between those, we have more items. So basically what happens here, we have the first 2 items, which are Microsoft and Chicago here, and this is the same document we had originally. But again, because this document is also talking about Microsoft and SQL Server, and this one is related to also the first document, we can see it also extracted this document and this concept too. So seeing connected objects is way easier with a graph database management system. Let's get back to the slides now. Let's talk a little bit about the Microsoft graph and not anymore the Office graph. So why is Microsoft investing into a graph? Before the 2013 generation and the cloud and so on, data used to be in silos. So you have all the document stuff and the business portal and so on in SharePoint, all the emails in Exchange, all the conversations in Yammer, all the voice calls and so on in Link, and so on and so on. And it was very complicated to get, for example, all the conversations talking about a document which is related to maybe this phone call and so on. Doing queries about data across the different workloads, well, is still very complicated. Another thing they discovered is that search simply doesn't work. I'm not saying that the SharePoint search is not working. It's great. Don't mistake that. But when you have to search for something, it's too late. Things should be naturally and proactively proposed to you, and you should not have anymore to search for things because it's a waste of time, basically. And then once you have everything, one other thing is, which could be great if we were able to achieve that, is pointing new things. Maybe if we have a lot of emails between this division and this guy, and a lot of emails between this guy and this other division, maybe this is because actually this division should directly contact and connect with the other division, sending less emails to the guy in between, and having more direct interactions, more efficient interactions. So because you have connected data and so on, you will be able to have some BI reports about how people are communicating and the data within your company. So what is Microsoft Graph? So we have multiple things within it. We first have the Azure Active Directory authentication APIs, plus the what we call the Azure Graph, which is more about identity of people. Then we also have the Office 365 unified APIs to files, groups, sites, mails, and so on. And we also have what we call the Office graph, which is actually insights about all this data. I will talk more about it a little bit later. If we have a look to what it brings together is, again, one endpoint for which is graph.microsoft.com for the unified APIs, the authentication, the insights of Office graph, and also not yet it's not yet available, but also extensions points for third-party vendors. So companies like SAP, like any third party will be able to connect their objects to the Office graph at some point. Again, what you will find in it is data from SharePoint, from Skype for Business, from OneDrive for Business, from Exchange, Yammer, the video portal, the search, the Office clients, and the Azure Active Directory, and even more things as all the Microsoft different teams start pushing more and more data into that, and as other third-party vendors are able to push more data into that. The way Microsoft defines the graph is based on three objects, which are the nodes, the actors, and the edges. The nodes are any kind of object, so it can be a document, a meeting, conversation, and so on. The actors are actually people, you, me, everybody. We are actors, and that's it, but that's only for real persons, not for things like rooms or anything like that. And then you have the edges, which are the signals sometimes in the documentations, and it's only the way to connect one node to another node or one actor to another actor. So that's how they define their data structure. Here is some example of edges. We have the example for modified. I, as an actor, have modified this document on SharePoint. As an actor, have modified this document on OneDrive, and so on. You also have the edge, which is viewed. As an actor, I have viewed this document, and so on. But you have also things coming out from the Active Directory. For example, my manager, my colleague, and so on. And then you have what I've put in blue, what we call the insights. So basically what they do, they take all that data, that connected data in the graph, and on top of that, they apply some machine learning and clever calculation. And what they do, they provide you new endpoints about what they thought that might be relevant. So for example, training around, and we'll see that later, is an endpoint where you have all the documents training around me. So everything. For example, in my company, I'm a SharePoint expert. I'm working on Azure. I do a lot of development. So the trending around endpoint will bring up a lot of documents talking about these subjects. Working with is another insight based on all the emails I send every day, all the conversations I have on Yammer, all the documents I work on and other people work on too. It will pull up all the people, well, the actors, that might be in my team based on that calculation, or might be working with. And on every edge, you have some properties, some standard properties like the actor ID, the object ID, the action type, the time, the weight also, because edges can have different importance, which is weighted, and so on. And some nodes properties, you have all the properties described in the documentation, plus everything that you put for SharePoint content in the search schema. So if you extended the search schema using site colons and index properties and manage properties, you will find these properties on your SharePoint nodes. Why is that? Because a big part of the Microsoft Graph is based on search capabilities and the indexing capabilities. So this is why it brings all the information back. If you want to extend the graph, because you are a third-party vendor, you sell some applications and so on, right now you don't have any API currently available. So you can't right now push new kind of objects, push new edges, and so on. But that should come out soon, I guess. But you can still use the SharePoint metadata, and you can also use the Office 365 Unified API to push some new documents, push some new meetings, and so on, which will appear in the graph. So if we have a look at what we have and what we don't have, right now what we have is the graph endpoint here, which is used by consumer devices and so on, and which is connected to the Office graph and Office 365 service and Unified APIs. And we also have the Azure endpoints in order to allow applications to use the graph, but also to have information about the user's identity. What we don't have currently is the third-party API for third-party vendors to be able to push new content, new kind of nodes and edges directly to the graph. So a short demonstration about how to play with the endpoints. What I've done for you is I've already executed some requests for the against the graph endpoints. So if you make a request to this endpoint as an authenticated user, here, so graph.microsoft.com/beta/me/files, what you will have is this answer. If we have a look at this answer, what we can see is we get a no data answer with the user who is concerned. We have then two kinds of objects coming out, the folders, for example. So in my OneDrive, I have some folders which will be listed here. One folder, another one with certain properties and so on. Another request we can have a look at is this endpoint, which will give you information about the user, and who it is. So again, request on my on one particular user, and what I will have, what kind of information will I get is, for example, what plans do I have? Am I able to use SharePoint, Power BI, Exchange, and so on? Then I have some common properties like the city I live in, the country, my actual phone number, and stuff like that. And then I have other informations like my SIP address and so on. So again, that gives you useful insights and information about the user. If we have a look at another request, this endpoint will give you well, same thing as we got before, but different, in the meaning that you can specify the user you want to have access to, and it will only display you the content that the current user issuing the request has access to. So again, the graph is not something magical sharing your files and your information to everybody. It's always security trained because it relies on the search capabilities and the search index. So the only thing a user will get querying the graph is the information he has access to, and that's it. So if he doesn't have access to it, he won't be able to see it in the graph. Now let's talk about the insights. So for example, working with, again, this is an endpoint Microsoft published to get information like who is this user working with. So for this demonstration, I've used the production tenant and not anymore my personal development tenant to get some actual data. So based on the again, the conversations I have, emails and so on, the working with Insight will give me data it figured out. So in my team, I'm working with our developers, which are listed here, and I will have some properties. And again, if I issue another request on these people, I will have other information about these persons. Let's have a look at the last insight available, which is trending around. Again, I've used the production tenant of my company to do that. So I, as a developer in my company, I publish a lot of documents about things we develop actually, like architectural document, analysis, and so on. Again, based on clever calculations and so on, this endpoint will give me files that might interest me, or I'm working on, or I'm working around, based on what it finds in my OneDrive for Business, SharePoint, Exchange, Yammer, and so on. So it can be useful to get things like documents to prepare a meeting and so on. Let's get back to the slide. So all that being said, one of the questions you might ask is, okay, but what is this going to be useful for? One of the cases I like to demonstrate is the Mavention meeting app they're demonstrating at the Ignite. So check out the Ignite sessions; those are great. What they basically did is an app for Outlook using the graph endpoint to get things like when I'm about to have a meeting, I have a meeting with some person and so on, which has a subject and so on. So why not using that to pull out all the documents that might be useful in order to prepare my meeting or to have a meeting. So that's what we basically did. And if we have a look at the screenshots, basically how it works is even in Outlook Online or Outlook on premises, for every meeting invitation, we will have related documents, the documents related to the meeting. We will have information about the people attending to the meeting. We will have some information about the opportunities in Dynamics CRM. They will also have the cases open for that customer or so on if they find anything in the CRM. And then we will have the news coming out from the news capability of the CRM. Displaying in that application, which is actually a great insight to prepare a meeting. So now let's conclude this session. Talking about tools before we finish the sessions, you have, if you don't want to issue manually the HTTP REST request, you can use the .NET implementations of all the service calls. What you have to do is install the NuGet package Microsoft.graph-pray to have the preview version of it, and you will be able to use high-level APIs, high-level .NET APIs in order to query the graph. If you want to play with the graph endpoints, not having a tenant, not having any development tools or so on, you can always use Graph Explorer 2.azurewebsites.net and also the API sandbox.tmsda.com under the unified API category. Other tools which are useful to you are the Azure portal and Office 365 if you want to query against real life data and also make real life applications. So to conclude, Microsoft is right now making huge investments on the graph, so stay tuned on that. They will soon publish news and new capabilities to the graph. Right now we only have 2 insights endpoints, and which are working with and trending around again, plus the whole Office 365 unified API, which already gives you access to a lot of data, but not to everything. The extensibility opportunity is coming soon, but it's not yet available, and it will all of this will allow you to make awesome applications, either using connected data to integrate with your application and to have a clever application, or integrate some line of business data and push it to the graph, so you can then relate it to other things that you might not even have considered before. To go further, you have other sessions about the graph at the Collab 365. You have the Ignite sessions. You have a lot of links in the slide deck. Check out Neo4j and the ebooks they provide. It's awesome. They really do a great job at introducing you to the graph theory and so on. And check out dev.office.com. They will publish anything like the documentation, like demonstrations and so on as soon as it's available. I have other sessions at this at the Collab 365. Two of those are in French, which are Traduire SharePoint de A à Z, which is about translations and managing a multilingualism. The other one is l'importance des métadonnées en entreprise, which is about metadata and how it's important to use metadata in a company. And the last one is setting up your release pipeline for SharePoint. So it's how you can use Azure and Visual Studio Online to do some automated build, test, and quality assurance for your SharePoint developments, either applications or full trust solutions. Thank you very much for attending this session. I hope you had you learned plenty of great stuff. Stay tuned and watch the other sessions of this great event. And if you have any questions, feel free to ask this in the Q&A or to reach me out via Twitter or my blog after the event. Have a great Collab 365 event. Bye-bye.